We were studying about different types of corn up to last episode 28. In this episode 29, degree calculations English episode 29, we started to study about different types of irregular jobs. It means you may have seen some jobs, its bottom side may be a square and its top side may be round. Bottom side may be a square and its top side may be a round. Since today we study about these kind of jobs and its developments. We haven't completed different types of corns again. We have to study about considering thickness. We have to study about if those corns top end reaches in sides or some other places, how will it be? We have to study about it. We will study it in coming some episodes after completing these kind of square to round jobs. It means bottom side it will be square and top side it will be round. Here its square is 800 into 800 and diameter of round is 400. We are going to make this kind of one job. First of all, we are studying about not considering its thickness, because if we consider about thickness, it is some more congested. Sometimes you may be a new student in fabrication field, so it may make congestion in your field, in your fabrication life. So without thickness, today I am teaching you. Even if it is so, if we consider thickness, what kind of changes may be occurred? For that purpose, I just tell about a square which is having a thickness of 3 mm and it is having a length of height of 500. It is ordinary square type job from top to bottom, 500 long height. Today we don't study about its development. We are studying about the development of square to round job. It is having square of 800 to 800 and diameter of 400 and its vertical height is 500. Not inclined height, vertical height is 500. Before that, we shall just think about thickness. One job, its top side is square and bottom side is square and it is having a height of 500. Then how will it be its developments, measurements? It is having 3 mm thickness. Remember, bending happens at the corner. So there will be sharp end corner will be formed. Its outside there will be curved line. So outside to outside is 300. Then bending line should be how much? Here I have written 794. Why? Its development is this one. Its height is 500. I have indicated here 500 and it is having 4 portions. These 4 portions, first portion, second portion, third portion, fourth portion. These 4th portions have to have 3 bends. 1 B, second bending, third bending. Then these 2 ends, this one and this one will be reached together and this place we have to weld. Then this it will be formed. For making this one, Most of them may get mistake. If somebody doesn't keep accuracy, they may write 800 to all sides. Afterwards they will bend, they will get more lengthy, widthy, this kind of square job. That is wrong. If we have to get to 300, 800 outside to outside, we have to decrease 1 3 mm from here, 1 3 mm from here. If we decrease 3 plus 3, 6 mm from 800, we will get 794. From here to here is 794, here to here is 794. This one is 794 and this one is 794. So, total length shouldn't be 800 into 4. Total length will be 794 into 4. And its height is 500 because it is height has been indicated 500. So this is the difference when we make a bending, sharp end bending. But when we do its rolling and bending is having a slight difference. Bending is done with sharpened punch. And its downside there will be V block. Some other places instead of sharpened we can use curved portion also. Even if it is so, all bendings will have one male and female part. Bottom side female part will be V block type thing and top side punch will be its male type B. Okay. So, if we do its development, remember its inside length has to be returned because bending happens there, 794. I have indicated it here. From here to here it will be 794. It won't be 800. 800 will be outside. What happens? It happens in sharp end bending. But this is curved bending. In another way, we can say it is rolling. In rolling, how much we will be taking? How much we have to take for rolling? For bending, we have to take this much, we have to decrease, and from 800 we have to decrease this much and we have to take. If it is so, how much we have to take? If we have to make a round, it is having a foramen thickness. Example, I am telling you foramen thickness and it is having a diameter of 400. Which diameter is this one? Here I have written OD. Outer diameter is 400. Then well, how will be its perimeter? How much of length it will be taken? Its length you have taken, its width you have taken. Same way, take its length and width. Always you will be using the formula P is equal to pi d. Everybody knows for calculating perimeter, we have to use the formula pi into d, or d means 2 times we have to multiply r. So both are same. R into 2 is d into pi. Both are same. If you like to use this formula, you can use this one or you can use this formula. Okay. With this formula, how will you be calculating the proper perimeter of this round job? For example, it is also having a height of 500. Earlier we were considering about 500. And its OD is 400. How will you be calculating P? For calculating P, we know pi is 3.14. P is equal to pi into d. Pi is 3.14. For diameter, what will you be writing? Here we have written OD is 400. But if it is OD, what will be its ID? ID means inner diameter. The diameter starts from here and it ends here. That is ID. OD is the outer diameter. That starts from here and it ends here. Then OD is 400. Then it's what will be its ID, inner diameter? We have to decrease 400 minus 4. Again minus 4. 1 4 is here. Another 4 is here. 2 4s. It means 8 has to be decreased from 400. Then we will get ID. 2 diameters are here. One is OD, another one is ID. Which diameter we will be applying here? That is my question. In one episode, I have told some episodes before 5-6 episodes. I have in that episode, I have taught you it. Remember, when we roll, the materials which is lying in outer surface will be spattered, will be gone out to out. It will be spread out to out. So, if these outer materials are having this kind of difference, inner materials are coming together. These two operations happens when we roll it. Outer materials are going out, going far away from one material to another material, and inner materials are some more closer. They are coming together to, they are coming very closer. So, outer diameter is correct. Outer diameter won't be considered as a perimeter. Inner diameter also shouldn't be considered as a perimeter. Then, what should we be considered as the proper perimeter? In between this 4 mm, middle, it means proper center means this measurement for proper center is 2 mm. In 2 mm area, one round make, in that round, whichever materials are there, it won't have any change in between rolling. It won't be increased or it won't be decreased. It is called, in between one round material is there, that is called MD, minor diameter, medium diameter. This is medium diameter, means it goes in between outer diameter and inner diameter. Inner diameter is the diameter of inner surface. Outer diameter, OD, is the diameter of outer surface. But when we consider its perimeter, we have to use MD, medium perimeter. So, in this equation, P is equal to pi D, pi we have written 3.14, D as we have written, what should we write? The measurement from this dotted line to this dotted line. How much it will be for this OD 400 diameter shell? We have to decrease 2 mm from here, 2 mm also from here. Then from 400, if we decrease 2 mm here and 2 mm here, how much we will be getting? Its OD is 400. Its ID is 4 has to be decreased here, 4 has to be decreased here. Just decrease, then you will get 392. Then what will be ID? 2 mm has to be decreased from here, 2 mm has to be decreased from here also. So, if you decrease 4 mm, 2 plus 2, 4. 4 mm from this 400, we get 396. This should be the proper diameter we have to consider for perimeter. Okay, this 396 applied to this dashed line. In next diagram, I have indicated it. Outer diameter is 400, inner diameter is 392, median diameter is 396. So, when we calculate P is equal to pi into D, pi is 3.14, D should be 396. Use your calculator and calculate. Then you will get this measurement. Don't see this video as a cinema or film. It is a class. It is a fabrication class. It is a mathematics class. It is the class of development. So you have to use your calculator. Otherwise you won't study. Okay. Now, again, one more example I am telling you about it. First, we told about a job which is having 3 mm thickness. Then, what kind of changes will be occurred when we will be bending it. And I told about a round job. It is having a perimeter thickness of 4 mm. When we roll it, what will happen? Again, I say about one job which is having 12 mm thickness, and its inner measurement is 800. And when its top side is round, it is having a diameter of MD, medium diameter of 400. When we calculate these kind of jobs, square to round jobs, if its measurement is like this, always it is round portion, it is square portion, bent portion. Bent portion, true lengths have to be taken from this corner to this corner. It means that corner is this one. This is that corner. This is that corner. Its outer surface will be like this because our plate cutting will be in marking. You will be cutting in 90 degree. So it will be, this cut will be going from here to here, not to here. Cut will be going like this only. Cut will be going like this only, not in horizontal level. Cut will be like this only. Cut will be like this only. And some special occasions, I shall come to that point. Before that, I would like to say some more thing. We are going to make a square to round job, bottom side square and top side round. So when we take its development, one measurement we have to take. For making a round job, considering perimeter, for considering its perimeter, we used medium perimeter, not outer diameter, not inner diameter. We used inner diameter and inner perimeter. We used medium diameter and medium perimeter, like that. If it is a square to round job, it is having two portions. The square portion is there in bottom side and round portion is there top side. So top side, when we consider, we shouldn't take its outer measurement which starts from this corner to this corner. Like that, we shouldn't calculate its inner corner starts from here and here. We should take the measurement of medium diameter. It starts from in between these two lines. Okay, that is the speciality of round portions. But this job is having another place in square area. There, which line we will have to take? This line has to be taken. From this line, bending happens. Inside, one line is there, sharpened bending happens. Inside, one line is there, corner is there, bending happens. Okay? Remember, what is this much of length? It is the job of 12 mm thickness. So, this taper length will be 12 mm. So, this taper length will be 12 mm when we look from this front view elevation. So, for calculations, if we have to get this line, we have to decrease 6 mm from center line. This is center line. This center line comes here. But we shouldn't take this as true length. We should take this corner as true length. How much this will be? From here to here? 6. Total thickness is 12. If we make one center portion here, and if we make one horizontal line to this side, this line will be okayed. Then from here to here will be 6 sum. Okay. Another one thing we told, when we cut one job using gas cutting or some other places, we will be cutting using straight cutting, 90-degree cutting. So it happens like this here, like this here. But some places, some jobs, if somebody asks this 90-degree cutting shouldn't be like that, and this material has to be increased some more up. It means from this inner corner to up one line has to reach there. That kind of one job we need. If somebody tells like that, our cutting has to have change like this, and in some, then our calculation also, development also will have changes. But ordinary way we do like this. In some other cases, somebody tells we don't want cuttings from 90-degree, or we don't want cutting from this corner to up. We want cutting from this corner to horizontal line like this. Then special calculations we have to take. This measurement or this corner also we have to calculate, and we have to do beveling. We have to make a special V cutting. Here also special V cutting comes. Here also special V cutting comes. This is the enlarged view of this area. MT is 400. Okay. Come to the point. In coming episodes, I will be teaching you about if it is having this kind of vertical line to up, then how much of accuracy we need, how much of difference we have to take when we take its development. This one also I will teach you in coming episodes. Coming episodes we shall expect. If bottom side is square, the round is there, but the round is not in the proper center. We are trying to find out a job, its center is, round is in proper center. But if round has come to one side, or if round has come too far away from center line, or if its round is having some other changes, here it is square area, top side is round shape, approximate round shape, but it is having inclination. So how will it be? I will teach you about this kind of jobs. I will teach you about this kind of square to round job. This is also called square to round job. This is also called square to round job. This is also called square to round job. But what is the difference? Its top side round is having inclination from proper center line, proper center of the square. Here inclination is here inclination is also there, and round is also having tapering. Okay. Here, what is the speciality? Here, bottom side is round and top side is square. This kind of jobs development also I will teach you. If here also bottom area is round, top is square, but top is not in the proper center, top is far away from round. Then its bending will be coming from this corner to here. From this corner to here. And this corner to here, and also from same corner to here. And from this corner to here, and also from this same corner to here also. From this corner to here, and also from same corner to here also. In between, so many bending lines have to be there. I will teach you about this kind of jobs. And if it is not having a shape of round or square, if it is having irregular shape like this, no, look, here it is in the square, Square is having only 4 sides, but it is having 1, 2, 3, 4, 5, 6, 7, 8 sides. If it is having 8 sides, or if it is having 6 sides, if it is having 5 sides, or any other sides, and its top side is not round, if it is having elliptical shape, or if it is triangle shape, those one also will be studying in coming episodes. So, okay, we shall come to the point. We are going to make one square to round job. We are not considering thickness. So, we use the measurement of square is 800 to 800 and its diameter is 400 and its vertical height is 500. Remember about 3 measurements. With these 3 measurements, we are going to make development. If we have to make its development, we have to divide this round into some parts. Now, for teaching you, I have divided it into 12 parts. 12 parts are there, but half portion I have written here. Coming part, 6 part is also coming here. If it is 1 is here, 1 will be coming here also. If 2 is here, 2 will be coming here also. 3 and there will be 3. 4 and here also will be 1 4. If it is 5 here, 5 is here, 1 5 is here. Same way, in square also I have divided with some marks. If it is 9 here, this one is also 9. If it is 8, this one also 8. It is plan and it is elevation. If it is plan, if it is 0, that is top side of the round. So I have indicated top side of 0. For making you understand very easily, one dotted line I have shown. 1 is also top side. It has been indicated in here. 2 is also round portion, so top side. Those one also have been indicated here. It is top view plan. It is front view elevation. Same way, 3 has been written here. 4 has been written here. 5 has been written here. 6 has been written here. 7 comes in square. Square is in the bottom side of this job. So, 7 has been written here. 8 is in square portion. It is also coming in bottom side. 8 also I have written like this. This 9 is in square portion. 9 comes in bottom side. 9 has been written in bottom side. 10 also comes in bottom side. 10 also in this corner I have indicated. Okay. How will we be making its development? If you make development, some bending lines have to come from 9 to 0, 9 to 1, 9 to 2, 9 to 3. Afterwards, bending lines will be from 8. 8 to 3, 8 to 4, 8 to 5, 8 to 6. If we make lines from here, same lines have to be drawn same time from opposite side also. Then our work will be finished very easily. Okay. So bending lines will be like this approximate. From 9, so many bending lines are going to the quarter portion of this round. This is square and this round is the proper center of square. So quarter portion bending will be there, but it is like a rolling. Bending lines shouldn't be visible after bending. That is the skill of a fabricator. Only sharpened area we will see in this corner only. 4 corners we will see sharpened bending. Another area we shouldn't see sharpened bending. Instead of that, it is to be immersed with this plain area. This is plain area. 8 to 3 and 3 to 9 and 9 to 8. One triangle is there. That is plain area. Same plain area is here also. This is 8. This is 3. This is 9. This triangle also plain area. This triangle also plain area. Like that one triangle is here also. 9, Here also 1 9, then 0. This triangle is plain area. There is no bending, there is no rolling. Same plain area is here also. Same measurements with 8 to 8. 8 is there. 8 to 8 and 8 to 6 and 6 to 8 is a plain area. Okay. We shall start our development. Okay. First of all, remember, we have to find out the true length of one measurement. We shall start our development from here. Anywhere we shall start. But now I teach you to start from here. If we start it from here, we will draw from here to here. If we draw from here to here, same time, we have to draw from here to here also. Okay. What is true length? True length means that length which is visible as perfect, proper. That is called true length. Its short form is TL. And some lengths won't be visible as perfect from top view or from elevation, front view. That is called a non-true length. So we have to take the proper true length. We'll see one measurement from 0 to 10. Is this a true length or not? It isn't a true length. Why? This 0 is top side and 10 is not in top side, that is in bottom side. So this 0 to 10 is visible from top side. Plan is not a true length. It is having more length. Listen, 0 to 10 is having more length. But when we look from top side plan, we will be seeing it as a small area. So, for finding out the true length of 0 to 10, what we have to do? What is true length? This will be true length. Because when we look from front view, our eyes are reaching in the 0 to 10 line really perpendicular way. So it is true length. Then how will be its measurement 0 to 10? How will we calculate it? I have taught you about some formulas. A square plus B square is equal to C square. Through this, we can find out this measurement. We shall make a triangle like this, means from here to here and from here to here and from here to here. That is a triangle. If we make a triangle, with that triangle we can find out, yes, we can find out this hypotenuse length using the formula A square plus B square is equal to C square, or C is equal to A square plus B square. I don't describe about it now because in earlier episodes I have explained about it. I don't waste time. We have to study a lot of fabrication related developments. Okay. This triangle I have drawn here. 0, 0, 0 to 9, 0 to 10, 0 to 10. And one vertical line to up and to this. What is this length? Means 0 to this length. 0 to top side of 10. 0 to top side of 10. What is this length? Everybody knows this measurement from here to here is 800. Here to here is 800. Here to here 800 is a square. And top side diameter is 400. Vertical height is 500. So, this is 800. From here to here is also 800. Here to here is 400. If it is so, what will be this length? From 800, we have to decrease 400. Then we will be getting the measurement of this area and this area. Two areas measurement we will be getting. In this two areas measurement, one measurement has to be removed. Or it is to be divided by 2. Then we will be getting, what will be this measurement? This is 400. This is 200. This is also 200. Then total will be 800. So this measurement is 0 to top side of 10 will be 200. Once again, I wrote this triangle to here. 0 to 10. 0 to 10. This measurement is 200. And it's a vertical height. This is vertical height from top of this 10 to the bottom of 10 is 500. We told about it. Its vertical height is 500. Vertical height is 500. So, in that triangle, we have to write here 500 and 200. With these two measurements, we can find out the measurement of 0 to 10 using the formula C is equal to root of a square plus b square. Apply 200 square. Don't see it as a cinema. Use your calculator. I already calculated and I wrote it. So, you have to use your calculator and calculate. 200 square is this much and 500 square is this much. This is C. We have to find out C. For that purpose, these two have to be added. Then we get this measurement. Its square root has to be taken. Then we will get 538.5. What is this 538.5? 538.5 is the measurement from here to here. 538.5 is the measurement from here to here. 0 to 10. 0 to 10. 0 to 10 proper length is, true length is 538.5. So, in the list of true lengths, we have to write it is the measurement of true lengths, TL. 0 to 10, we have got 538.5. 0 to 10, we have got 538.5. That is in the list of true lengths, TL. Okay. If we have got 0 to 10 as 538.5 and if we get it, we have already got 7 to 6 also because it is a square. It's a proper center. One circle is there. How much of tapering it will be having? So same tapering it will be having. So there is no need for to calculate this 7 to 6 true length again. This length measurement will be same as this one. Okay. Now we can calculate the measurement of 0 to 9. From 9, we have to make some bendings to this quarter portions. Now I have indicated 4. If its diameter is so big, this 4 is not enough. We have to use more than 4, more than 8, more than 16. Enough measurements have to be taken like that. If this measurement is so small, no need of 4 also. Sometimes 3 may be enough for bending. Sometimes 2 also. Okay. That is according to the diameter and according to the diameter of or the speciality of job. Okay. We shall find out the next measurement from 9 to 0. What is 9 to 0? Is this a true length? No, because 0 is in top side and it's parallel. 9 doesn't come, 9 comes in the bottom side of square. So, if we look from top side, 0 to 9 is not a true length, it is a non-true length. In front view also it isn't a true length because in front view 9 is so near to our eyes, 0 is so far away from eyes. So how will we be finding out 0 to 9 true length? How will we be finding out the measurement of 0 to 9? We have already got this true length. What is this true length? 538.5. We have already got this true length. This is true length because it is in ground level. If we look from top side, from our eyes view and this view are in 90-degree visible area. So 9 to 10 is a true length. What is this true length? From here to here is 800. Then it will be 400. Here also we can use the formula a square plus b square is equal to c square. This measurement is 400 square and this measurement is 538.5 square. I have written it here. A square plus b square is equal to c square, or c is equal to root of a square plus b square. One square is from here to here 400 square. I have written here 400 squares. This one is 400 square. Another one is 538.5 square. 538.5 square. Each square is just calculate in your calculator this one. Each square after adding these two, we have to take its square root. Then we will get 670.8. What is the 678.8? 670.8 is the true length of 9 to 0. I have written in the table of true lengths. 0 to 9 is 670.8. Now we got 670.8. If we got 670.8 as the true length of 9 to 0, same measurement will be coming from 9 to 3 also, because this is a square. Square's proper center one round is there. Its quarter portion will be having same length at both ends of quarter portions. So if we have found out 9 to 0, we have automatically we got 9 to 3. Same measurement will be there from here 8 to 3. Same measurement will be from 8 to 6. Same measurement will be coming from 180 is here, 8 to 6. Same measurement will be coming from 8 to 3. 3 is here also. Same things are happening in this opposite side also. If we have got 9 to 0, 1 9 is here, 9 to 0 we have already got. If we get 9 to 3, same 9 to 3 is here also. So we shall mark first of all 0 to 10 as the development. How much we have got 0 to 10? 0 to 10 we have got to 538.5. 0 to 10 we can mark here as 538.5. From here to here 0 to 10. Next measurement is 10 to 9. 10 to 9 is real 90 degree from 0 to 10th line. If we look it taper away from this area will be 90 degree. So 9 to 10 will be 90 degree area. So what is this 10 to 9? 10 to 9 is 400. 800 divided by 2 is equal to 400. So from 10 to 9 in 90 degree we have to mark 400 here. We have to mark 400 here. That time itself we have to mark to left and right. If you mark to left side, that time itself 9th right side is also marked. our work will be decreased. Okay, and if we got 9, from this 9 we shall mark 9 to 0, 9 to 1, 9 to 2, 9 to 3. 9 to 0 we have already got now. 9 to 0 we have found out using the calculation of a square plus b square is equal to c square. So we have got 0 to 9 is 670.8. We have got 670.8. So from 9 we can mark 0. Already we have marked. We have got that. When we mark 0 to 9, 9 to 0, same measurement will be from 9 to 1. But same time we can mark step by step we have to mark. So we shall find out the measurement of 9 to 1 also. Remember, if you have marked 9 to 0, that time itself we have to mark 9 to 0 from here also. Okay. Next is 9 to 1 we can find out. 9 to 1 finding out. 9 to 1. How will we be finding out the measurement of this area? It is in the true length. For finding out the true length, we have to get this measurement. If we have got this measurement, from this measurement, downside is length is vertical height is 500. One measurement we will get like that. That measurement and this measurement has to be drawn as a triangle, and then we will be finding out 9 to 1. I shall describe it using diagrams, then you will find out it. Okay. We are going to find out 9 to 1. We shall find out 9 to 1. I just draw this round. I have drawn this round which is having a diameter of 400. We have divided it with 12 parts. 12 parts are there, but for teaching you quarter portion I have taken. 0, 1, 2, 3. For teaching you only 0, 1, 2, 3 parts have been taken. 0, 1, 2, 3. These parts have been taken. Through this, how will we be finding out the distance from this corner to 1? We shall make one triangle from C to 1, 1 to up and to here. For finding out, one diagram I have shown here. C to 0 I have drawn one line, C to 0, and C to 1 one diagram I have drawn, line I have drawn. From this one line has been drawn to up, which reaches C to 0 line in vertical, reaches in vertically 90 degree, it reaches there. So remember about the triangle C1 and it reaches in this corner. What is this length? Everybody knows this diameter is 400. If it is so, this is radius. It will be 200. I have indicated it here 200. If it is 200, then how much will be this measurement? And how much will be this measurement? You know, I have taught you about some formulas: sin theta, cos theta, tan theta. Using these measurements, calculations, you can find out this measurement and this measurement. Everybody knows. This round has been divided by 12. Total round for finding out, for drawing one round from this line to this line, we have to make it rotate 360 degree. We have to make it rotate in 360 degree. But this portion, 0 to 1 portion, is one part of 12 divisions. So 360 has to be divided by 12. Then this degree will be 30 degree. This kind of 30 degrees will be formed together 12 times, and 360 degree will be formed. So remember, this degree is 30 degree. Using this 200 and this 30 degree, we can find out this measurement and this measurement. Okay, I have taught you about sin theta, cos theta, tan theta. So I don't describe. Formula of sin theta is opposite side by hypotenuse. Formula of cos theta is adjacent side divided by hypotenuse, and tan theta's formula is opposite side divided by adjacent side. In this three formula, which formula will be applicable here? If we use the formula sin theta is equal to OS, opposite side divided by H, hypotenuse. What is this opposite side? Sin theta is degree, I have written here sin 30. And for opposite side, we don't know. I wrote their opposite side, and H is from here to here is H, that is 200. I have written here 200. With this formula, how will we be finding out opposite side? We have to keep opposite side here, and we have to take this 200 to left side. If it is in the bottom side, when it reaches the top side. I have taught you about it earlier episode, so I don't describe it. If it has been divided here, when it reaches there, it will be multiplied. It happened here. So opposite side is equal to sin 30 into 200. Do your calculation using your calculator, then you will get opposite side as 100. What is 100? 100 is the measurement from here to here. That is 100. Total degree is 360, and this inside of this degree is 30 degree, and using this formula, 30 degree, we used sin theta is equal to opposite of hypotenuse. Then we got this measurement as 100. This measurement as 100. We have got that measurement as 100. Okay. Come to the next diagram. It is our job, square round job. Its length is 800. This length is also 800. This length is also 800. This length is also 800. This round is 400 diameter. And using this 30 degree and 200, we got this 100. If we have got this as 100, what will be the length from here to here? Total length from here to here is 800. From center to here is 400. From center to this much is 100. So this 100 has to be decreased from 400. Then we get 300. This measurement is 100. This measurement will be 400. If we add these three, we will get this measurement. 400 plus 100 plus 300 is equal to 800. Okay. We used the formula. So we got 100 here. For finding out this one, we shall use the formula a square plus b square is equal to c square, or We can use the formula cos 30. Cos 30 is equal to adjacent side divided by hypotenuse. In this two formula, one formula has to be used. Here I have used the formula cos 30. Instead of cos 30, I have used cos 30. Cos 30 is equal to adjacent side divided by hypotenuse. Hypotenuse 200. Adjacent side we don't know, so I wrote here adjacent side. We have to find out adjacent side, so I kept adjacent here and I have taken this 200 to here. Then 200 has been multiplied here. 200 has reached in top side. Use these two, multiply these two, then we will get 173.2. What is 173.2? From here to here is 173.2. I have written it here. From here to here is 173.2. Okay, we have got this much of measurement, 173.2, and from here to here is 200 because its diameter is 400. Then how much this much of measurement will be? From 200 we have to decrease 173.2. Then we will get 26.8. Do it in your calculator. Then you will get from here to here is 26.8. So we have the measurement from here to here as 173.2. From here to here, now we got 26.8. And from here to here is 200 because this is 200. This is also 200. And this is 400. 400 plus 200 will be 800. Okay. Now we have got this much. We have to find out the true length of 9 to 1 using this 226.8. This is 200 and this is 26.8. Using this 226.8 and the measurement 300. Using this 226.8 and the measurement 300, we shall use the formula a square plus b square is equal to c square. Then we will find out this 9 to 1. But it won't be true length. It will be the top side of 1 to the top side of 9. Not the bottom side of 9. In another way we can say this answer a square plus b square is equal to c square of this triangle will be the answer of bottom side of 9 to the bottom side of 1 only, not the top side. So using this formula we will get one measurement that will be a hypotenuse. That hypotenuse has to be used a square plus b square is equal to c square with a vertical height of 500 mm. Our vertical height is 500 mm. Our vertical height is 500 mm. So we shall find out that measurement first. First of all, we shall find out this measurement. Afterwards, this measurement square plus vertical height square. Vertical height means 500 square. One measurement will be got. These two measurements have to be added. Its square root will be the true length of 9 to 1. Okay. Now first of all we had to find out the length of 9 to 1 which is visible in plan, not in true length. Okay. 226.8 square. A square plus b square is c square. A square 226.8 square is this much. Take it in your calculator, then you get that much of measurement. Take your calculator and calculate 226.8 square. 226.8 square. 226.8 square is equal to, we get 51,438.2 and 300 square. 300 square is, there is no need for you to calculate in your calculator. Everybody knows its measurement will be 90,000. I have written it here. This 2, it is c square. For finding out c, its square root has to be taken. So first these 2 have to be added. When then we got it, its square root will be c. 376.1. What is 376.1? The measurement from here to here. That is the visible length from plan only. That is the true length. For finding out the true length, 376.1 square plus vertical height square. Vertical height is 500. So we shall use that formula 376.1. Now we got 376.1. In plan, we got 376.1. This is in earlier diagram. And 326.8 we had already got here. Sorry, 226.8. And this measurement is also 300. Both are being drawn once again to 300 and 226.8. Using these two, we use the formula a square plus b square is equal to c square. Then we got 376.1. It is the length visible in plan. This is plan. Once again, I write it in 376.1 here. 376.1. That is the ground floor plane length. Ground floor plane length. From ground floor plane length, 190-degree line has to be drawn to up. That has to have a length of 500 because 500 is vertical height. So using these two, we will get 625.7. How will we be getting? There also we have to use the formula a square plus b square is equal to c square. C is equal to root of a square plus b square. A square, 376.1 square is this much. And b square, 500 square, that is this much. These two have to be added. Then we go to this. Its square root will be found out. So, its square root is 625.7. Do it in your calculator. Don't see it as a C number. A square, 376.1 square. 376.1 square plus b square, it is 500 square. 500 square is equal to, we get this measurement. Its square root has to be got. Square root is equal to, we got the measurement 625.7. What is this 625.7? That is the true length of 921. 625.7 is true length. This 376.1, this 500. Using this measurements, we got 625.7. It is ground floor plane length. So what is this 625.7? That is the true length of 921. So we got most of the true lengths. 921. Its true length is 625.7. Now we got, if we have got 921 true length, if we have got 921 true length, already we have got the true length of 92 also, because it is square. Square is proper center, one round is there. The length from 9 to 1 and the 9 to 2 will be same. If it is same things are happening here also. Here also 1 9 is there. 9 to 1 is here. 9 to 2 is here. That is also same. So if you mark this left side, right side also we have to mark. This 9 to 1, 9 to 2 are same in 8 area. 8 to 4 and 92 are same. 8 to 5 and 8 to 4 and 9 to 2 and 9 to 1 are same. Same things are happening here also. Here also 8 is there. 8 to 5 is here. 5 and 8 to 5 here. Same. 9 to 1 is same. Okay. When we find out this, most of the measurements we have got, most of the true valence we have got, we have to get the true length of this only, 0 to 1, 1 to 2, 2 to 3. If we get that also, all measurements will be good. How will we be finding out the true length of 0 to 1 or 1 to 2 or 2 to 3? Calculate the perimeter. How will we be calculating the perimeter of for calculating perimeter? We use the formula pi d. I have taught you it in earlier episodes. It is 400 dia round. Pi is 3.14, diameter is 400. We do this all without considering thickness. Multiply these two, we will get the measurement 1256.6. That is the perimeter of this round, 1256.6. When its diameter will be 400, its perimeter will be, P will be 1256. But we have to get the measurement of 30-degree area, 0 to 1 area, or 1 to 2 area, or 2 to 3 area. So for that purpose, it has been divided by 12 portions. This perimeter also has to be divided by 12. Then we get 104.7. So that true length also we got. All true lengths we have got. 0 to 1 true length also we got. First we got the true length of 0 to 10. It was applicable for some other ones also. Again we got the true length of 0 to 9. It was applicable for 8 measurements. Again we got the measurement 1 to 9 or 9 to 1 as 625.7. It was applicable for 8 areas. Now we got the true length of 0 to 1. It is applicable for 12 portions. Okay. We shall do the all true lengths are here. With this true length, we can draw this pattern development. How will we be? Up to 9 we have drawn. 9 to 0 we have already drawn. 9 to 1 measurement, what is that? 9 to 1 measurement is 625.7. 625.7 we have to draw here using compass. Where will we be this one reaches? For that purpose, 0 to 1, how much it will be? 0 to 1, how much it will be? 104.7. 104.7 have to be marked here. This is also 104.7. This is also, all are 104.7. From here to here 104.7. Here also 104.7. If whatever we are marking here, same thing has to be marked here also. So 9 to 1 we have marked. That time itself we have to mark 9 to 1 from here to here also. Then 1 to 2 here we have to mark. 1 to 2 is same as 0 to 1. 104.7. 104.7 has to be 4.7 has to be marked. Again 104.7 has to be marked. What is this length? 3 to 9. 9 to 3 and 9 to 0 are same. 9 to 0 are same. 670.8 has to be marked. So 9 to 0 marked. For finding out 9 to 1 measurement is there. 9 to 1 measurement has been marked. Where will it be crossed? For that purpose, 0 to 1 measurement, we used 104.7. We got 1. If we have got 1 here also we have got. Again, we have to get the measurement of 2. For that purpose, whatever measurement we have drawn from 9 to 1, same measurement is to be drawn from 9 to 2. For crossing 9 to 2, 1 to 2 measurement we know, but not 4.7. It is to be crossed. If we have drawn 2, same 2 has to be drawn here. Next is 3. For that purpose, this measurement we know. This measurement also we know. 9 to 3. 9 to 3 is same as 9 to 0. 9 to 0. 9 to 3 is same as 9 to 0. 9 to 3 is same as 8 to 3. 8 to 3 is same as 8 to 6. If you have drawn these measurements here, same measurements have to be drawn there also. How will be 8 to 5? 8 to 5 will be same as 9 to 1. 9 to 1. 1 to 9 is 625.5, 625.7. 625.7 has to be drawn here. Afterwards, 9 to 5 measurement you know, 65 you know. Finally, we have to get 7. Finally, we have started our drawing from here, 0 to drawn. Then we drew 9, 9 to 0, 9 to 1, 9 to 2, 9 to 2, 3 marked. Same marks we have drawn from here also. Afterwards, we have to find out 8. 9 to 8 is 800 length. Where will it be coincided? 8 to 3 has to be marked. What is the measurement of 8 to 3? Whatever we have got the measurement as 9 to 3, that measurement is the measurement for 8 to 3. From 8 to 3 has to be marked, 8 to 4 has to be marked, 8 to 5 has to be marked, 8 to 6 has to be marked. For finding out exact location, this 3 to 4 line has to be crossed. If you have drawn some measurements from here, same measurements have to be drawn from here also. So we reached up to 8 to 6. Last one is 7. If we draw 7, our one half round will be finished here. Same time, one half round will be finished. Same here. What is this 8 to 7 measurement? From here to here is 800. Then it will be 400. 400 has to be marked. Where will it be coincided? For that purpose, 6 to 7 measurement has to be found out. What is 6 to 7? Same as 0 to 10. What is 0 to 10? 0 to 10 is 538.5. If 0 to 10 is 538.5, same will be 6 to 7 also. 6 to 10, 0 to 10 and 6 to 7 are same. So, if we have drawn 7, our one square to round jobs perimeter development will be finished. Okay, in next episode, I shall teach you about round to square, means bottom side will be round and the top side will be square. Okay. Thank you very much for watching.